Hello there, my name is Yizhi from the University of Cambridge. Now, if you give me 3 minutes, I will explain to you why it might worth yet another 30 minutes of your life to have a read-through of our real paper on Integrated Photonic Recurrent Processors, or as we call it, IPRPs. So what are IPRPs to start with? If I may direct your attention to my piece of superbly drawn art here, it is showing what we call a conventional photonic accelerator, or in another sense, a single-pass processor. At its core, you have this photonic kernel representing the mathematical operations that you decide. It can be things like convolution, matrix factor multiplication, doesn't matter, as long as you find a functionality for it. But the catch though being, when you put signals through the structure once, it hits this wall and eventually hard stops. So what is this wall? It's actually the interface between the photonic and the electronic domain. It constitutes all sorts of architecture overhead, things like the DAC, the ADC, and the data shuttling delay. For this hybrid operating system, it's obviously the bottleneck that we want to eliminate or at least minimize. So the question being, is there a way that we can actually bypass all of these? What we found out is that when you can devise a sensible logical connection between the input and output pair, you're setting yourself for the possibility of replacing this chunk with simply the optical delay memory, or in other words, a feedback system at the caveat of an appropriate recurrent kernel to compensate for the operation that you desire. The idea being that when you are in this PRP setting, then you're doing your computation non-stop at the speed of your propagation, and it should offer you efficiency in both time and energy. Sounds all fun, right? The question might be that seems like we're running at a set of rules here. Does that confine the range of activities we can do on these processors? Well, in fact, in our review, what we found out is that there's just a wide range of applications that can be mapped onto the recurrent architecture, starting with things like linear solvers to neural networks to reservoir computing and to Ising computing. So certainly a lot of room for you to explore here, but not gonna give you any more spoilers at this stage, and as I promised, my 3 minutes is running out. So I hope you find this interesting, and we're gonna see each other very soon for the actual paper.